at specific heat capacity today, and after experiment we realised that some substances heat up better than others. So some of them take ages to go through 5 or 10 degrees in temperature change, and some of them do that very, very quickly. So that shows that not all materials heat up at the same rate. The reason for that is that each different substance has something called specific heat capacity. And what specific heat capacity tells you, I suppose in simple terms, is how well it heats up. But in scientific terms, it tells you how much energy it takes to raise the temperature of 1 kilogram of that substance by 1 degree Celsius. So for example, water is given as with a specific heat capacity of 4,180 joules per kilogram degree Celsius. That means that it takes 4,180 joules of energy to change 1 kilogram of water by 1 degree Celsius. That leads us to our specific heat capacity equation, which is EH equals Cm delta T, where EH is the amount of heat energy that something has. If you give that more of a temperature change, then it's going to have more heat energy. Specific heat capacity, remember that's the measure of how well it heats up or cools down. M is your mass, as always. Delta T, anytime you see that triangle, a delta means a change in, so it's a change in temperature in degrees Celsius. So that shows you really that the amount of heat energy that something has depends upon 3 things. It depends upon how big it is, or how small it is, what its mass is, the temperature change that you apply to that, whether it's big or whether it's small, and also the specific heat capacity, how hard or how easy it is to heat up that particular substance. So we looked at a simple example of how much heat energy would be required to raise the temperature of 2 kilograms of alcohol from 20 degrees to 65 degrees. So delta T is given, there it's 45, you've got to calculate that out here. 2 kilograms is your mass. The specific heat capacity you'll get from the second page of your standard grade credit paper, which looks a little something like this. And that gives you all the specific heat capacity values for the various substances that you're going to be asked on. Now notice also that it gives you the units as well. You don't need to remember the units for specific heat capacity. They're given right there in that table, so I wouldn't maybe try and remember them because they are quite difficult. Just refer to it there, but sometimes you might have to come to this to get your value. So this is the value that we used within that particular example, 2,350. From then on, it's really just straight substitution, and then you've calculated the amount of heat energy that is required. Sometimes you're going to have to calculate what C is, in which case it's just EH divided by M times delta T. It's just a standard rearrangement of the formula from there. But specific heat capacity tells you how difficult or how easy it is to heat up a particular substance, and that can be used in the design of houses, in the design of factories, in the design of electrical appliances. It really depends on the situation, whether you want to have something that holds heat well or something that takes ages to heat up. So it's used in the design of all sorts of things.